Ah, the wonders of science, and specifically about space exploration. What's going on in this world anyway? The planets, the stars, the moon. You have questions, and because you had questions, we have answers. You've probably seen plenty of images from Mars and all the craters that exist on it. And that begs the question, just how many cooked pinto beans can fit in those craters on Mars? To accurately calculate the volume of cooked pinto beans that could fit in all the craters on Mars, you have to actually delineate what kind of craters you're talking about. There's actually two kinds. Volcanic craters are formed by the vent area at the top of a volcano. Known as Mar craters, these are formed when magma and water interact, causing a highly explosive eruption. Impact craters form when a meteoroid, asteroid, or comet collides with a planet. If we think about just impact craters, we have to know that there are 43,000 impact craters on Mars that are at least 3 miles in diameter. Compare that to roughly 120 here on Earth. There are 635,000 craters on Mars that are at least 1 kilometer in diameter, or 6/10 of a mile wide. In order to figure out how many cooked pinto beans we can get in there, we have to figure out what the volume is of all the impact craters that are at least 6/10 of a mile wide. So the truth is that we really don't know the exact size of every crater on Mars, so we're going to have to come up with, say, an average. Well, we know that if we say that each of the craters is approximately 1 mile wide in diameter, we can come up with a very rough estimate of what we think the total volume of all the craters on Mars is. And once we know the total volume of the craters, we can figure out how many pinto beans we can get in there. Now, speaking of pinto beans, we know that this 1 pound bag of pinto beans, when cooked, would equal 3 of these, or 6 cups. If we cook 20 bags of these, it would fit into this box here. This happens to be 1 cubic foot in volume. So the question is, how many of these will fit into those craters on Mars? Well, it turns out that it's a very big number. Each crater would contain 73.5 billion cubic feet of cooked pinto beans. All of the craters taken together would take 46 quadrillion cubic feet of cooked pinto beans. That's 4.6 with 15 zeros. So that leads us to the all-important question of, how are you going to cook all those pinto beans? I love science. It's well, gravity. It's everywhere, isn't it? No matter where we go, we look and stuff's falling from the sky. But what if the Earth doubled in size and therefore we had twice the gravity? Well, first of all, trees like that one wouldn't be as tall. Trees get their nutrients from groundwater. The water then has to fight gravity to get to the top of the tree. The taller the tree is, the more energy the tree has to use to get the water up to the top. If the energy the tree gets from photosynthesis is greater than the energy it takes to get the water to the top, the tree will grow. With gravity doubled, trees would have to be shorter to get their nutrients to the top. Bones would have to become more dense. As more force pushes down on the body's structure would have to be stronger to support the additional force. Buildings could collapse. Buildings that were built to withstand the downward force of the current amount of gravity and no more wouldn't have the structural integrity to support the additional weight they'd have to hold up. A force twice what they were designed to hold up may be enough to bring them down. So life on Earth would be more challenging if the Earth doubled in size and therefore had twice the gravity. But that's all well and good, but the real question is, can you dab on the Earth if the gravity was twice as big? You know what? Let's leave that to the professionals.
Hey! Look at my dab. Look at my dab. Look at my dab. Look at my dab.
We have to remember that twice the gravity means twice the weight. Walking around on Earth would feel like carrying somebody the same size as you on your back. Your heart and lungs would have to work harder under the additional stress, and movement would seem much more difficult. So the answer to the question of whether you could dab on Earth if it had twice the gravity and what it would feel like is, you could, but it would feel like you were wearing a suit that weighed as much as you do. So yeah, you could do it, but it would take quite a bit more effort. It's a beautiful fall day out today. The sun is shining. Oh, speaking of which, kids, don't ever look directly at the sun, even if you're wearing sunglasses. Speaking of the sun, just what's going on there anyway? Is it moving? Is it like a flame that'll eventually burn out? Although the sun is hot and it provides light, it's not actually a flame that might one day burn out. The sun generates energy by a process called fusion. Hydrogen is converted to helium in this process. Most of the heat is generated in the core and it is transferred to the outside of the sun. It reaches Earth by solar radiation. Only about half of the solar radiation that hits Earth makes it to the surface, but we still feel its warmth and benefit from its light. Well, now that we know what the sun is, the question is, could we move Earth closer or farther away and still survive? If Earth got even a relatively small distance closer to the sun, it would be too hot. Much farther away and it would be too cold. This puts us in a narrow band called the habitable zone. So of course the importance of maintaining ourselves in the zone of habitability is that we need water to be maintained in its three forms. We need it in a gas form, we need it in a solid form, and of course we need it in liquid form. All living organisms need water to survive. Without water in its liquid form, living things could not survive. Our place in the solar system allows us to have the ideal atmosphere for survival. Any movement closer to the sun or farther away would destroy the atmosphere we need to sustain life. Okay, so the sun is just the right distance from the Earth to make it habitable. But is the sun moving? The sun is moving. The whole solar system actually orbits around the center of the Milky Way galaxy and is moving at a rate of 828,000 kilometers per hour. We know the sun is an important part of our solar system, but how do we know how big it is? We can measure the diameter of the sun by poking a hole in a piece of aluminum and projecting the sun on a piece of paper. The relationship of the size of the image and the distance to the hole in the aluminum is proportional to the distance to the sun and its diameter. You can actually do this experiment yourself at home. Of course, scientists use much more sophisticated methods. The sun is an amazing thing, and fortunately we have a few billion years of life left in it, so not to worry so much. Oh, that reminds me. Where did I put my sunscreen?